Hi all, welcome back to my channel. Today I am going to tell you about data modeling. So this video will be an overview about data modeling. For the people who are new about data modeling, for them it is useful. Let's start with this. In this video, I'll be covering what is data modeling, what are different types of data modeling, and then the elements of data modeling means entities, attributes, relationships, and then at the end, tools which we can use for the data modeling task. So, to start with, what is data modeling? So, data modeling is similar to what we create a model before any construction. For example, if I want to construct a building, in that case, first I will visualize like which kind of building structure I want, how many floors it should have, how many rooms it should have in each floor, which kind of room I want, which kind of balcony I want. All those things I'll visualize and draw in paper before actually going to start and creating the building. Because without visualization, without a picture in front of me about what I need to do, where I need to place rooms, where the kitchen will be, etc., it is very difficult to directly go and start constructing. We might have to face many problems if we directly go in the field and start working without creating a model. Similarly, data modeling works. In data modeling, as the data is getting stored in the database, so how the data will get stored, how to organize the data, which are the different tables we need, what are the different columns we need, how the tables will get connected with each other, all these things at the very first stage when we get the attributes from the business. At very first stage we'll gather the attributes and create the data model. So this is the very beginning of our any project development. In the data modeling, we use various tools and software these days to create a data model. If I talk about the history of the data model, in till 1970s we didn't had any relation database, and everything was light on papers or in the file system, etc. But after that it got evolved, and now we are in the very advanced stage of a data modeling, I would say. And then let's talk about the three elements of data modeling, which is the entity, attributes, and relationships. I will explain this in the upcoming slides. And data modeling life cycle. Data modeling life cycle, as I said, it is the different phases of data model. So once we create a data model, it will go through various phases to actually implemented in a particular software. So first is the conceptual data model. Conceptual data model means which is very near to the reality. Okay, if I have to create a data model of a school, then what kind of data in a school we will get? We will get the teachers' data, we'll get students' data, we'll get subjects' data. All this data I will get, and how these different like entities, how the teacher, students, subjects, all these things are related, I will define that. And this kind of starting model is the conceptual model. Then we have the logical data model. Logical data model will go bit into depth of the conceptual data model. So this is the enhanced version of conceptual data model. It will talk about different constraints or rules. So if we know that that's a normalization we'll do on the database, it is having 3NF, I mean, I will not say 3NF, but it is having normal forms. Like what are the different normalization means? We have some rules, like if you we should have we should not have any duplicate data in the database. Okay, all the different columns should always get identified by only one primary key. Okay, and then all these different rules when we bring into the picture, in that case it is the logical data model. And the physical data model is again the enhanced version of logical data model, but it will have the tools and technology constraints. Means if a tool and technology is having some constraint, we have to follow that while creating actual physical data model. Okay, so now we have basically in broad way two types of databases or systems. One is relational and one is analytical. So in relational, it is basically used for the daily transactions. So whenever in a database we are doing daily transactions, for example banking system, daily we are doing some transactions, or any hospital database, all these things are having daily transactions. So for that we use transactional, and we create transactional data model, which includes tables, columns, entity and its relationship, all those things. It is basically entity relationship model. It follows the diagram and etc. I will explain everything in detail. It's just an overview which I am giving. And then we have analytical data model. Analytical data model, as its name suggests, it don't follow any entity relationship things, but it is used to store the data, which is huge data. It is kind of archive data or huge data which we have. Will use analytical data model, where we use this data for analysis, for reports, for any AI BI things. We use this, and here we use facts and dimensions. Now, if I talk about the three main important ingredients to create data model, then we have entity. Entity is the subject area. Okay, it can be an object, it can be a class, it can be a person or place, means any noun. Okay, that we call as an entity. Okay, if I take the example of a school, then I have teachers, I have students, I have subjects, I have classes. All these things are these sub entities. Okay, so this is the entity, and we have two ways to represent this in the diagram, or when we create data model in a designing tool or on paper also. So in the right hand side you can see model. This is entity relationship model. Here we define entity in a box. So student is an entity, I am defining that in the box. And then we have crow's foot model. Here what we do is we go in bit depth, and this is the student, which is an entity, and here we define its attribute also, means primary key and other attributes. So this model is basically more inclined toward the conceptual data model, and this crow's fit model is more inclined toward the logical model. And also we have two types of entity: dependent and independent entity. So an entity which is dependent on the other entity, that is dependent entity. I can give one example for this. For example, if I have if I have attempts, okay, attempts and exam. So attempts will only come when we have exams. So attempts is an dependent entity on exams. Okay, so an independent is like student, teacher, these all are independent entity. Now, data model attributes. What are attributes? These are the properties which describe an entity. Okay. If I want to describe a student, how I will describe a student? The student must be having some name. The student must have some address where that student reside. He or she will have some contact details. So all these things which we use to describe that student are known as attributes. Okay, so in and we have different kinds of attributes. We have key attributes, like which are the main attributes to define. Then we have composite attributes, means two or three attributes combined to define one attribute. For example, name is an attribute which is combined of first name and last name. So this is composite attribute. Then multi-valued attribute means which is having more than one value. For example, context or phone number. It might be possible some students will have more than one phone number. So this is multi-valued attribute. And so these are the different kinds of attributes we can have in a data model. And there are some rules which usually when we do the logical data model we have to see before defining an attributes, which are the data type and size of the attribute. If I am defining any phone number, then the data type will be your integer or something. If I am defining name, it should be string or character. Okay, so like this. And whether attribute having null value or not, means null valued or allowed or not. If I am having any primary key is what it is, means the basic key on which entire entity is defined. For example, if I talk about a student, how I can differentiate between all the students? By the student number. Student number or enrollment number will be the only number which is different for each student. So the primary key is the unique value which each and every record or each and every student should have. So that is the primary key. And the other keys, for example, name, so two students can have the same name, so that is not the primary key. Okay, so when I'm defining a primary key, means enrollment number or student number, that should not be null. There cannot be any student which is having no student ID or no enrollment number. It cannot be possible. So null values are not allowed here. But if there is an contact, if I take contact, so there might be a student who don't have any contact details, who don't have number at his for him to contact. So that can be, can be null, it depends, but the primary key cannot be null. So this constraint we have to define. Okay, then we have permissible values, which values are permitted in a particular attribute. Okay, if I'm defining an attribute as a student number or enrollment number, then I cannot put their name. Okay, I have to only put the number. So only numbers are permissible in that particular attribute. Strings, it should not take any string value when we input it. Okay, and then other constraints as per the requirement we can put. Okay, and in the ER model, if I see entity relationship model, when you design a data model, how you will define? You will have an entity student, and these are the different attributes which comes in the oval shape. A student will come in the rectangle box, and this we have to create a link between this. So this is the ER model. And in the crow's foot model, what we do is we have to mention the primary key here, means the unique key which distinguish between all the different members of that entity, and then we have other attributes which define that particular entity. So this is how we define that in the crow's foot model. Then we have relationship, how the different entities are related. Entities, as I said, it's noun. Okay, so how the student and teachers are related. Okay, so student and teachers are related means teacher teaches student, or student taught by teacher. So there is a relationship. Teaching is the relationship, means teacher teaches the student. So that, to define that in the ER model, we will have the teacher here, we have the student here, and here we have this diamond shape where we'll give the relationship name. Okay, whereas in the crow's foot model, we have these entity here, student teacher, and here like a simple line will get the relationship name. Then we have cardinality of the relationship. Cardinality means how that student and teacher are related. Okay, if I take about teacher and student, it is many to many, means there can be many teachers for a one student, and there can be many students for one teacher. Okay, I mean, in a class, only one teacher, like maths teacher, can have maths student. Okay, but a student in a school can have many teachers. For example, maths teacher, science teacher, history teacher, and all this. So many to many, this relationship is many to many. Okay, and if I talk about any other relationship, for example, university, so it is one to many, means one university can have many students. Okay, but all the students should only be enrolled to one university, so that is one to many. So these are different kinds of relationship we define, which include one to many to one, and many to many. So this is the different relationship cardinality, and this is how we define. Then hierarchies in data model. So in data model also we can define in more detail. For example, we can have a parent child relationship. Here I have taken an example of faculty member. So a faculty member is a parent, but it can be of two types, a permanent faculty and an ad hoc faculty. Okay, so this both are related with the faculty member as is a relationship, means faculty member is a permanent faculty or faculty member is a ad hoc faculty. But if it is a permanent faculty, or it is a ad hoc faculty, or it's a faculty member, all these will have some common attribute, which is id and name. All the faculties will have their id and their name. So all the common attributes I will define only at the parent level, and the unique attributes which are only for permanent and ad hoc faculty I will define at the this particular child level. For example, permanent faculty will have their tenure year, but ad hoc faculty will have their contract length, because after some contract their contract would get over. That's why we call them as ad hoc faculty. So what happens is, when I have this parent child relationship, whatever attributes I'll define at the parent level will get inherited automatically to the child level. Okay, then so this is the end of this video, but before ending this, I wanted to tell you a few things which are very important. So once you start in your organization to create a data model, you should very well know what are the subject areas, how the subject areas are related to each other, and what are the attributes. Okay, then there are different model, or there are different er model, or classic er model, or crowsfoot model. You can choose any one and you can use it. Okay, and this data model is not only at the starting stage. Okay, we have to define it at the starting stage, but this keep getting evolved as the project runs. Okay, suppose I have some attributes which are now, suppose earlier we were not having phone, or if I talk about like 20 years or 30 years back, we were not having phone. So contact detail might not be an attribute that time, but as the this evolved, contact detail become an attribute. Or now it is not there, like every student is having laptop. It is not there in our Indian schools. They are having books, and it's like no, digital education is not there. Okay, but in future laptops might come, then we have to have a laptop as subject area, and then we have to have a laptop id. And also this thing, the data model, we should keep evolving. But in the very first stage, the data model should be very clearly defined, so that when we actually implement it in the reality, we will get very less complexities, and it will be very easy to implement. Okay, so it is, see, it is not a rocket science. I can help you if you want in more details in the next coming videos. Just because I wanted to give an overview here for the people who are very new, I have created this video. And here are the different tools what we can use for data modeling. And there are many, but I have listed few. For example, erwin data modular, toad data modular, we have oracle sql developer, mysql. Then if we talk about cloud, then we have microsoft azure sql database, and archie. So these are different tools what you can use. They have like drag and drop designing capabilities, and they do have all the constraint what you need to include as a logical data model. Everything you will get here. It is very, these are all very nice tool. And some of these are free also. I mean, like oracle sql developer, mysql, archie, these are free. So you can also practice by taking your dummy data and can create. So this can be helpful for you. So here I am just closing, or I'm at the end of this video. I hope some of the information might be useful for you. And in the next few sessions, or in the next few videos, I'll be coming up with the Hindi videos also in the same topics. So keep in tune. And if you have any questions, if you want me to come up with any other topic, do let me know in the comment section. And thank you. Have a nice day. Bye bye.